this is the importance of automated testing. So yeah, I'm going to close the chat because a few of my work colleagues are in there and they're known for heckling. So what is testing? What do I consider testing? So testing for me covers all sorts of aspects across your product, your site, etc. So that's like a lot of things. So that could be code style. It's static analysis is another form of testing. It covers where you're checking how things should work together and should talk to each other. Browser and end-to-end testing, that's like how things interact with your browser, how like when you request part one, it then goes on to part two and checking all those parts. And then the other bit, which is what most people would consider testing, is unit tests or feature tests or functional tests, and those bits and pieces. So all of these for me cover testing. Like they all test different parts, and all of those bits people do as developer. You do those manually in your head, or via like various different tools. So like when you go do a code review and you're checking somebody else's code and you're reading it and you're going, right, I don't like that the space is not here, or if it's not this bit, or like the bracket should be on the next line. That's a code style check, and that's a code style test. When you're looking through the codes and you kind of can see that this is going to be a problem because there's you're passing like the value a word or a string through when it should be passing only class names, or where you're passing a number instead of passing a boolean, for example, and it's going to error. That's a type of static analysis. That's still an in-person test. And when you're going around clicking and entering the forms manually and doing QA and all those bits, that's a browser / end-to-end test. And when you're like writing when you write a test script or your own script, like kind of thing, and you kind of say like put a load of scratch code together and you kind of go, okay, I want to check that this does this when I write this bit. That's a unit test. It's just not kind of formalized. So all of those are forms of tests or testing. So I'll go through some of these now. So like with code style, for various different ones, there's various different automated tools that people have created and will help cover these ones here. So for code style, we have a few. We have like PHP Code Sniffer. We have PHP CS Fixer, which is mostly used like for Symfony, etc. We have the copy paste detector. It's a kind of code style check. It checks to see how many times that you've copied and pasted and like duplicate codes, etc. All of these, there are plenty of others as well, and you can do the same kind of ones using your IDE, your like you can even use PHP itself to do some sort of code style check by basically saying like it's not got any obvious faults, but each of these extra tools give you more functionality and more control. The next one is static analysis. These ones allow you to have different manner of various different parts that will allow you to kind of check like how code is going to talk to each other before you get to the point where it's the code is running in production. Because a lot of errors that static analysis will pick up will be ones that are deal with like where it's picking up a value from a database and it's like that is being converted as a string, but you're expecting it to be a number, and that will end up being like a fatal error and causing an application to crash, etc. But you kind of, by seeing this, it kind of can look through all the code, look where things are calling and go, oh, this is going to cause you a problem. You might want to fix it. And some of these tools you might have heard of or might not have. And so PHP Stan is one. Psalm is another that made by Vimeo. PHP Metrics is another one that kind of pulls out a bit of its different bits. So all of those are kind of some tools that you can use for those particular bits. So browsers and end-to-end testing, they basically are covering interactions by using a browser. So usually they will be written in a way that will allow you to control and issue commands to a browser, like go to this place, visit this page, do this, look for this particular element, click on it, and kind of do those interactions. They can be not always written in PHP. We have a couple that have PHP interaction layers, some that are JavaScript, etc. Mainly because of that is where a lot of people want those bits. There are even plugins that you can get for your browser which will read certain script and configuration files to actually do this. So some of them, like there's Cucumber, Selenium HQ, Laravel has one called Dusk, and there's Cypress, which is a JavaScript NPM installed one. I've mostly tackled here with Dusk, and this builds upon a unit test style system to and extends upon that to run in a browser. So you can tell it to start up a session and go to a place, find this element, click it, etc. And then see how things interact. So if you've got like a JavaScript layer and you want to know that the JavaScript validation library that you're using, you can like have that test and go through and have all those conditions. So this then goes on to our last section, which is unit tests or feature tests. They have different names. Generally, the idea of a unit test is that it's testing a single piece or a single unit of code in isolation. The biggest one and most well known within PHP is phpunit. We have pest, which is a new player, which is a syntactic wrapper around phpunit. So you would, when you write a pest test, it basically under the hood compiles that to a PHP unit test and allows that to be executed. It also allows you to use the pest code for making checks, etc., inside unit tests, so you can cross bandy when you've got them in use. There's also codeception, which is an old, like a one that doesn't get a lot of verbal or lots of talk about at present. It still goes strong and it's still pretty good. And then there's PHP spec, which is a different concept of testing, but still falls under kind of like unit testing and functional testing, etc. So all of these tools that cover all of these premises, etc., have different ways of doing different bits and pieces. I will cover the first off. We'll go through what I use for PHP Code Sniffer for code style. So for code style, for PHP Code Sniffer, I find that it's quick and easy to start with. So all we have to do to get started is to use Composer. I'm assuming everybody here has used or uses Composer. So we've got the Composer require. You say that you require the Squiz Labs PHP Code Sniffer. Once that's completed, you can run it from the vendor bin PHPCS and you tell it what standard that you want it to run. I chose PSL 12 because that's the standard that is the current one that covers PHP 7, 4, and 8, etc. PHP Code Sniffer has plenty of extensions and abilities. There's lots. I've just picked a couple of here. Slevermat is one that basically covers a lot of the more nitty gritty kind of specifics, um, like strict types enabling, making sure that certain extended upon rule sets, etc., can be applied. WordPress has its own coding standard, so you can, like, if you're writing WordPress code, you can like validate that your code meets the WordPress standard. And there's a few others as well that have the same standard. There's also a PHP compatibility coding standard, which allows it to run through and target in particular problems that are on an upcoming version of PHP. Unfortunately, like with a lot of open source projects and a lot of open source parts, the people that are maintaining these are few and far between, and they so like they don't get as much option to kind of continually to keep up. So PHP is releasing versions quicker than people are helping and supporting Code Sniffer, etc. And that's the same for PHP CS Fixer and the others. But PHP Code Sniffer is configurable and has a plethora of command line arguments that you can use to just tell it, like, to use a full standard, which is a whole list of of rules and what they call sniffs. Or you can specify like a comma separated group of sniffs to say, hey, only run these sniffs against this code. And you can say, okay, run it everything in this folder, excluding this folder, or anything that matches this, all of which are configurable from the command line. Though the command line does get a bit wieldy. And if you are running through most of these on a regular basis, I'd recommend using their XML config file so that you can then share that standard and setup before it. And then you can just say, use the standard command, as you can see on the quick easy start there, to point to your your config file, etc. You can say, hey, I want to use this standard over here. And I constantly apply it. And then any extra sniffs and pieces of details can be added to your config file to say, hey, my extension, my standard, like kind of moves and extends upon the PSR12. It doesn't include this one, so we want to exclude this sniff. We want to include this one, but not that one, and gives you all of that versatility. And finally, I like PHP Code Sniffer because it has some really nifty Git integration with the two of its filters of Git modified and Git staged. Git modified is any file that Git sees has been modified. That basically covers all changes that you have not yet made. So when you do Git staged, it basically covers all of the data that you've added. So when you do when you git add a file or git add a chunk of a file, and you do that across many, Git staged will check all of those ones that you have staged ready for commit beforehand. And you can include that in, say, with your own standard, with the PSR12, etc., all the other combinations of filters and command line arguments to kind of make it so that you can run those at a pace. And with Git, you can even put this into a post commit hook, or even a pre commit hook, so that it prevents you from committing if you're not meeting the code style standards. This becomes really helpful for maintaining group dynamic or teams where you're all kind of working in a similar style. Otherwise, two people may make modification to a line without understanding why, if somebody changes it, etc. having a shared code style means that you can get faster and quicker and cleaner code. Next, I'll cover the quick and easy for phpunit. We'll cover these bits here. So again, installing phpunit. Currently, phpunit's at version 9, 9.5, or I believe. But as long as you use the at least marker, the little hat or caret, then it will install that. And again, you can call it directly from the vendor bin folder to say, hey, run these bits. Here's an example of a really basic test case. So you can just say, here's a test. All the things need to, when you're running phpunits, it will scan through a folder looking for classes that and class names and file names that end with the word test. You can use annotations to kind of in your comments to kind of specify these, but for the most point, end the class name in test and it will pick it up. There are the same for actual test functions within inside your test case. You start it with the word test, and you can use underscores if you want, or kind of camel case, or you can name it however way you want and use the @test dot block annotation to kind of trigger it. With modern PHP 7.4 and above, 8, etc., I would definitely recommend using this standardized format of the word test at the beginning of it and then a descriptive of it. This one here covers the just as very simple but it's not really important test. It's just like saying test that this item has this bit. With each test comes assertions. An assertion is, hey, this thing, make sure that it matches what I expect it to be. In the case of this first test that I've got here, I've said assert that the items has the value 6 in it, which it should, and it should pass. To run the tests, you just run the vendor bin phpunit and you specify the location that it needs to look for. This also can be configured via a phpunit config XML file, at which point you don't have to specify the folder by default, but you can also apply filters, etc. up on that. Beyond that, there is pest, which you can which has a really good getting start guide, so I'm not going to replicate it here. But pest itself runs on top of phpunit, so when it runs, it will create a class underneath and wrap your code for you. So it's a different way of writing it, and some people find those easier to get started with than the regular phpunit. And phpunit has been around for a long time. They're working on phpunit 10 at present, which will be a very different beast under the hood, and will have a lot more extensibility, a lot more speed, etc., etc. But for the most part, this covers the basics of that. Part next, which it's like there are ways that you want to automate the testing, and so that you don't have to think about it anymore. You can do that in a few different ways. You can write some Git actions. You can like tell it to do certain other bits, but the ones that I'm mostly using are like kind of, we have GitHub or GitLab Actions, etc. ways that GitHub do those things through CI tools. BuddyWorks is one that we've used, which are basically just a way of running those through. You can run them in a classic Jenkins environment, like which is Jenkins has been around for ages. Anything that can say when this thing happens, run this command in this environment is viable for you to automate your testing. GitHub Actions are kind of quite viable these days because a lot of people have put effort into the ecosystem, so that you can say, hey, when I create a pull request against master, I want to run this this set of commands and build upon that, like check out PHP, like get the code, build up a PHP unit bit, and then run this test command. And then another one which says, okay, check it out, get code sniffer, make sure that's running, and run the code sniffer across it, and then filter those output to kind of place them where you need them with reports, output generated, etc. Even to the point where you can get emailed reports back when of failures. You can have parts where it filters it and reports back in line on the pull request to say this thing, this line is wrong, or this line has a problem, etc. So that covers the basics of all of these bits and pieces. I will now yield the floor for questions. I'll cover any of those topics, or kind of boot up a code editor if you want to see kind of some more practical examples, or any questions for anybody.
Cool. Any questions people want to post in chat, or feel free to unmute yourselves if you'd like. I didn't realize there were Git modified and Git staged filters for PHP CS, so I found that was really useful. So yeah, I can look into that a bit more. Do you have a particular convention around naming tests then? Because I think that's something I've always sort of found, maybe not tricky, but to be consistent with. You know, you get the whole, it must start with the word test, or you can use an annotation, but even just naming them. You know, I've seen some that just like get the title or something, or you can get the super long test names that certain people sort of say that they should start with like test that, or say that Dave Farley, I know, says it should always start with the word should, for example, as well, into more of a behavioral mindset. Yeah, do you have a particular preference, or what do you suggest? How would you particularly start?
So
naming these names?
For unit tests, etc., it's mostly explaining what it's testing, because each test needs to do a thing. If you're testing more, if you're going through and testing more than one thing in a test, in this case the test function, it soon becomes overloaded, and you can't then see what it's at points. So most of it is like testing the test that when user XY does it returns null. It's more like descriptive of those.
Yeah. That makes sense. It's just be quite interesting to write something really long like that with the sort of the camel case syntax. I know I see a lot of using snake case for function names, for test names, or I guess that's where pest could be quite nice as well, because it's all just one big long string. So yeah, you could even include things like colons or things that you couldn't use in a normal function name potentially.
Yeah, so that's kind of one of the benefits for those for it. So some examples on here, I've got test currency on.
Can't see your screen now, by the way.
Yes. I'll just do a quick. Yeah. So
people haven't put two and two together, at least I didn't for a while. Pest is the PHP version of Jest, which is the JavaScript testing framework. It took me a little while to put that together in my mind.
So like, for example, here we've got test currency on GBP. auction adds tax. So we can basically say that we're going to create a thing called a mock. A mock in this case, within like testing, a mock is a duplicate of a class or an object that you can say, we're going to do this thing and use this here. So that way we can like say, I'm expecting this thing to be called, and when this gets called, return this piece of data, so that you can substitute a known working thing with your dummy code or your test code, so that way you don't have actions and other bits run through. So for example, if you have an API that you calling on a service, you may not want to like have your service be called every single time that you're running test, but you know that when they call this with this piece of data, it's going to like call the API service, and that API service is going to return a bunch of objects or an array of data. So you can then use a mock to say, when I go through and call this thing, I'm going to expect that it's going to call this code on this class, etc., etc. So that's where we've got these things here. Like we've got like creating a mock of a fee here, and we're saying that we expect it to call get twice, and then each time it's going to have like fee amount and tax amount, and then it's going to return these values on those bits. Each of the way has its own language for how it does it. There's various different ones like mockery, mock, etc. But yeah, there are different manners of which you can do these. So, but yeah, they've got this one is this name. There are some longer ones. It's like test get mileage for display returns 0 when mileage is 0. So it's like, and then we've got a separate test here, test get mileage for display returns 0 when mileage is null. We could like test both of them and do it in one test, but it means then if either side fails, we would then have a failure on that test, and we wouldn't know which one is actually failing in which condition. So having them as separate when you've got different data is there. With the unit tests and the same for pest, it has its own manner. There's a thing called data providers, which basically allows you to specify a set of data to be passed to your test cases. And it basically says, so instead of like, for example, these two here, instead of it being like 0 and null, I could just say like test when it gets returns 0 with mileage value. And then I can pass in like null and 0, and then basically set those values up here, and we'd still get the same results. But then if there are more things that generate the 0, for example, then we can add those to our data provider. And that's like, for example, in this bit here, get listing ending countdown. So we set like our test time. We then basically create a new auction, a new thing with the right dates, and we get the value, and then we assert that it's what we're expecting. So here we're running through. These are the bits here. So we've got these. We've got all these are set up what we expect it to be, etc. These get passed through sequentially to these arguments, and then we're basically using the asserting to make sure that they're equal. And then like I can run this through, and you can see while there is only one test here, we are running 5 tests here. And it's like doing 10 assertions. which is like a nice little kind of bit. So we're repeating the same test with 5 different sets of data. And you can see here like the different ones. All of that is possible both in pests. Pests, I think, call it data set, or with that. I'm not fully versed with pest, but you can, in here it's data providers, similar kind of naming of different ways of different bits. But yeah, then as for the naming of the test, as long as it describes what it is doing and what it is testing, then it should make sense how to write the test and other bits. And then when somebody comes along later, they can read the test title and understand what it should be doing.
Yeah, all makes sense. Some of the ones I saw then, like it will return 0 when it gets null. If like I tend to pass it through the test docs sort of option, so it displays the whole test name in the output rather than just the dots and the things.
Yeah.
How does it handle that? Like, is it clear? Just sort of does it split that correctly? I guess is what I'm trying to.
Yeah, but mostly
Cool.
when it uses for test docs for the output format, it basically will take anything that is camel case and up so the capital letter is the word boundary, and for a number it will just put it as a single number. So
Okay.
if you have like 0, 1, 0, 2, whatever, it will have those as a single word. It won't convert them like from the number 0 to the word 0, but it will make
of course, yeah.
it will just have 0 as itself.
Mm-hmm.
But yes.
Cool. Very interesting. Yeah, I like some of those methods you have, little sort of helper methods, like there were custom assertions, but like mock will return this, so that was quite nice just to keep everything a little bit tidier. Like those were quite good. I just saw those a second. Yeah.
For a lot of our tests within for work, because we have a lot of repeated action, etc. We have like the helper methods in the base test. So let's that up. So so these are the other bits, like replace with mock. Because we're using Laravel, we basically say create the mock, which creates a mock version of a class name, class string, and then basically says, hey, Laravel container, every time that somebody says they want this class, give them this mock version. And then we return that mock object so that we can then interact with it. So we can then say replace with mock rather as one command rather than kind of doing multiple bits.
Nice. Yeah, I tend not to use too many mocks when I'm writing tests because I don't, in my mind, if I start saying when this will be called exactly twice and I go and refactor and my test starts failing and it still works, that sort of puts me off over mocking things. But doing some API testing recently, and I've sort of gone, okay, this seems, I've got a fake API client and that makes sense, but this particular thing, it makes sense to mock. So I can see myself doing very similar repetitive things. So I think just that little replace with mock is a nice one. So I might steal that.
Yes. So a lot of the times, mocking shouldn't be your default go-to.
Agreed. Yep.
Like it's there for when you have like a heavy service or something that you don't want to hit if you can avoid. So like if you're using, for example, here we're kind of using 2 services. We've got Mango Pay and Stripe, which are both payment gateways. When we're running through this particular test, we don't really want it to test. We don't really want it to hit those APIs. We don't care with it. We do care that it's calling those APIs. So that's why we're saying here we expect the service to have create user called once.
Yeah.
And the same for the Stripe here. We expect it to have the when we had the feature enabled, etc., we expect it to be called once. Otherwise, we would expect it to be called not ever.
Mhm.
So all of these are bits and pieces. But yeah, it's just various different ways, different bits. We also have, we use a kind of a few traits for our common access. So we have one here for Laravel, which is should not use database, which in our test case, base one here, basically after the application is created, we enable the query log to track queries which are run.
Mhm.
And then before the application is destroyed, we get the queries that have been run since the application was created. And if we basically say this query log, which is an array of queries, should be empty, and if it's not, then we fail the test. So we can then just because the way that Laravel does its test traits, etc., we can just say should not make it should not use database, and then if any of the tests have any of the code that runs interacts with the database at some point, that test will fail. And it's just an extra little kind of nicety.
Yeah, nice.
And we have various other ones here, like um, like interacts as a user, interacts with the fees, like we've got interacts with metrics capture, and all of these bits in here. These are some of these are old, and maybe we shouldn't really do these things, but yeah, with the once you kind of create a trait, it's up to you to maintain it to make sure that they're still in use, and
Yeah.
also that the way that it's being used is still the best way to be it used. Because as with any tool, as soon as you like, it's the same thing with the old adage for PHP. Like, what if you've got a hammer, everything starts looking like a nail. And it's the same with like creating traits or creating helper functions. As soon as you start having those, if you're not maintaining the idea is like of is this the best way to do it, you end up like start like trying to push everything onto them, and it becomes a problem. So yeah, Welder has had a question. It's like on large test suites, phpunit usually complains about slow tests. You should really speed up those tests. What are the best practice for building fast tests, and how do we prevent building slow tests? Slowness comes from the interaction paths. So the more complex the code that you're putting through and under test, the longer that it can run for. With Laravel, there's like the refresh database, etc., and the other parts which can cause slowness. There's an extension for phpunit which we use to track tests that run at a slower speed, um, just because sometimes we have problems with certain aspects and certain parts of it. But for the most part, if you're testing small and targeted aspects, and you are making sure that external services which may have slowdowns beyond your control, like APIs, etc., if you're not like if you're querying a third party or another company's API, if their AWS goes down or if something else happens, then it will slow it down quite a lot. So if you can mock those or even substitute them with a what's called a stub. So like we have one here called no send Twilio, which basically just extends the Twilio transport. So we don't this basically has all the rest of the code is the same, except for the point that it actually sends the message. It just kind of goes, I don't do anything. Which means that we're not waiting on the API, and we can like test everything else as we expect it to be.
Yeah, that's interesting. The thing I've seen done before, so you have one test case that runs against a fake, and another one that actually might go against the real API client. But you sort of put the actual test in a trait, so you still run the same tests against both. That's something I've been experimenting with lately. So most of my tests are being run really fast locally against a fake, but maybe in CI or something, it is going to try and run them against test API or something, if there is one. So yeah, this is another approach on that, I guess.
Yeah, there is various different tooling. If you've got like a JSON-based API, there's different toolings for creating like mock endpoints that you can wrap in a Docker container. There's various different tooling for creating different bits, so you can substitute outside of tests. So you can say, hey, when I'm running tests, the endpoint is actually localhost : port number 5476, instead of being like api.serviceprovider.com. And so that way it kind of responds in the way that you're expecting, and it can respond really at faster because it's running there. And you can like set up the rules that say, hey, when I receive a create customer and it has this ID, then you're going to return that it fails because it's missing this user detail, or provide this bit as per their specification. And so like different mocking of that kind of sense. Those bits and pieces are available, and yeah, all of those are ways of doing various different bits and pieces. It's just choosing the right avenue of and where to replace. Like if you're in control of where the code is, that's grand. If you're not, but you are in control of where your tests get run, maybe you're running a mocked service, etc. It's very much depending on like what's your outcome.
Okay, just looking out for any more questions. I suppose the one last one maybe for me then. We talked about a few different things. We talked about unit testing and static analysis and code sniffing and everything. If someone doesn't have any of these tools at the moment and wants to start introducing them, which would be the one that you'd recommend them starting with first?
It very much depends on what their common goal is. It's I like if you're constantly checking your code, and you've got like for example, if you're working together with somebody else and you're constantly getting code conflicts because like you've got different spacing or like this bit, and you're getting conflicts on multiple times, like pretty much everyone, introduce like code sniffer with the code standard, and then both of you can follow it. It will reduce your amount of conflicts because you're both then working to the same standard. If you want like reassurance that what your code is going to run in the same manner with the same bits and pieces, and then introduce past or phpunit, etc., to kind of go through those bits and pieces. It's every single one of them, like just it's get started, make it, get it going. And then if you find that it's not providing everything that you need it to, there's always ways to improve upon it. But if you don't have it to start with, then you're going to be doing most of those checks manually anyway. Automate it. It may take you a little bit of extra time to start with, But if you're say running through the code and doing, say we go with the code sniffer one again and the conflicts, the amount of times that it takes you to resolve code conflicts, if you take twice the amount of time that it takes you to resolve one conflict and put that onto say code sniffer, you can then forevermore prevent those conflicts except in the real extreme cases, at which point all of that time is saved and adds up, etc. And then you can look at adding things onto GitHub Actions, so that way you don't even have to worry about running it anymore. It just runs it automatically and reports back, which is very helpful for when you're talking to other team members, because for some reason people prefer to be told that their code is messy from a bot than from another human.
Yeah, we don't mind them being out of Jenkins or whatever the case may be, but yeah, also it's a waste of, not waste of time. It's arguably someone could spend their time better than doing human code review, like, oh, you've got too many spaces or missing a comma, whatever the case may be. Tooling can do that already. Cool. Yeah, I guess I was saying to someone recently, joined our team, and it was like, even though like we this project I was on, like there's no, I've added CI pipelines and started adding tests and site analysis and everything. And I was just like, just getting the first test in there is a win. Like everything doesn't need to be completely automated or have all the coverage to begin with, but we've started. Like that one test is infinitely better than having no tests. And then just keep, as we're adding new things or finding bugs, add a test case for it. And, these things will build over time. At least that's been my experience.
Yeah, that leads on to things that there are test-driven development practices, which is where you write the test first, then you write the code, and the test should fail. Like you write the test first, and you know that it's going to fail. Then you write the code, so that the test passes, and then you can then refactor the code, etc. There's the same thing for all of the bits when you're getting to unit tests and like feature tests, function tests, etc. When you're testing those parts, if you're testing what it's meant to do, not how it's doing it, you can then like change the underlining of how it does it, make it better, cleaner, faster, stronger, all of the Daft Punk terms, and effectively the test will prove that it continues to do what it needs to do. And but for the most part, write the test, write the code, get it working, because no matter what, you can always improve it later.
Indeed. Make sure you see it fail first. I've seen that on Twitter. Oh, my test passed first time. I'm like, great, but that could imply that it's not testing what you think it's testing. But we'll see.
I've had a couple of those over reviewing senior developers, like because they've written tests and it's gone through and it's been awesome and it's been perfect. Unfortunately, it was passing because they were asserting two variables that were similarly named. And instead of testing the two different variables against each other, they were testing the same variable. And that was because they had like one that had a number one and another one that had an L at the end. And so
is this anybody we know? Can we name drop anybody who may be involved?
I would not do so.
Fair. So, no, I'm joking, of course we wouldn't do that. But now I guess that's where we're getting a little bit off topic, but things like code review or just pair programming, they're going to spot things like that, aren't they? More good practices
if you're working in a team. Why automating your tests and running through these are great things, because like static analysis tools can like potentially see that you've used the two variables, and it's like, oh wait, this assertion is bad because you're testing the same thing.
Yeah.
But no matter all of the automations, all of the automatic testing, unit tests, etc., means that the reviews come down to code reviews come down to like improving and working together for the better outcome rather than nit what seems like nitpicks.
Yeah. And if you're working on your own, pair programming as a service would be quite fun. There we are. Yeah, done that before, done code reviews and things for people. Anyway, cool. Not seeing any more questions from the floor or in chat, as it were. One more chance if anybody wants to post something. So I've learned a few things. One I mentioned earlier on was PHP parallel lint is one that I've used for syntax checking rather than just PHP minus L. I guess it's faster because it'll run things in parallel, or at least that's what the name implies.
Yep. We've got for linting is now like most people forget about PHP minus L, mainly because of they're using like PHP Storm or Visual Studio Code, etc. And those have like code style syntax highlighting, and it kind of gives you like the red squiggly underline when you've got like problems. And so PHP minus L is like the basic. It will run through a file or a folder and basically say, hey, this is missing a semicolon, or like you've kind of got like a string here, wasn't expecting it. The things that you would normally expect elsewhere.
Indeed. Oh, actually, a question for Michael. Wrote a passing test, but the code wasn't working. I checked the test, I was asserting one variable equals another, worked out it was null equals null. Yeah, that would do.
Yep.
So to what we were just saying earlier on. Yeah, testing one thing is testing the other thing. Yeah.
So it's so easy to do that, especially when tests get really big, which is why I prefer to have lots of smaller tests. And why I use things like reflection, etc., to kind of access private helper functions. For certain aspects like that, I can reflect on a method. Like for example, if an object I've got has a public method which I can call, say, create a user, but underneath it says it validates the email, and the validate email is a method that checks the past user's email address, etc., to make sure that it meets criteria, or validating a password maybe on that object. But those are two protected or private methods. So I use reflections on some of those to so I can run a test and call those methods. So like I can test that code runs as expected, and then I can like just know that when I call create user, it's going to call those, and those are tested, and I don't have to worry about making make them test for them as well in when I'm caught testing it against the public API or the public interface for it.
So what you're saying is taking those public or taking those private or protected methods and sort of making them public so you can test them.
Yeah.
Just within the test.
Just for within that test, etc. Yeah, PHP Stan is great for that. There's a couple of PHP Storm plugins as well for Michael there. I was saying about PHP Stan advises them when
I guess for Laravel.
Yeah,
for Laravel, you put Larastan as well, which is
the Laravel
on it. Extension,
yeah. Cool. So there's a plugin for PHP Storm. It's the extended annotations. The PHP inspections EA extended. I'll drop the link into the Zoom chat. That one kind of is built into your into your kind of the IDE and gives like a lot. It gives quite a few nice little bits where you get different aspects, etc. So common problems, common things where you might be doing something which is like it reads and it makes sense, but when it's doing so, it's like maybe uses 3 times the amount of memory that you might want to do. The most common one that I had was where you're merging arrays of data together inside a loop. And where that comes up is like if you're merging, if you have an array of data, say dollar data, and you have like another set of data that you need to merge into it, and you're like that other set of data is constantly just like you just kind of fetch it from a source or like grab another database row and merge it in, etc. If you're doing that within a loop, those kind of things ends up like tripling the memory usage because you've kind of got your baseline array of your data, plus you've kind of got your data that you'll kind of merge in. Then you have your third one, which is the copy of the original data plus the merged in data as one new array. And then you kind of store that across that. So it's like you can quickly mount up memory usage without even thinking about it. And that this plugin kind of helped me kind of with that by pointing out that if I created an array of arrays, I can then use array merge to kind of merge all of them and flatten it after the fact. And that then does it all as like one efficient memory usage. And it for some of the bigger loops and parts that I've done, that reduced memory and also increased speed by like about 50% because it wasn't needing, it was just kind of, hey, okay, I'm just going to build this large collection, then flatten it.
Yeah, I loved the code comment above that. I'm doing this a slightly odd, weird way because this big explanation.
Yeah,
no, I think you're right.